today we're going to talk about Tales from Interop. The main point is how do we get core devs, so about 120 people, working on roughly 5 forks to not make everything super chaotic. So before we start, I'm going to set the stage a little bit. What is Pectra? So Pectra is the fork after Devcon. Devcon is the one that we shipped in March of 2024. That's with 4844. The scoping discussions kind of started earlier this year compared to the previous times. So we already had a general idea of what's going to go in Pectra in Jan of 2024. So client teams kind of started working and kind of started bike shedding what's going to go in. Naturally, since we started early, we overpromised or over-committed what we wanted to do. And by May, we had EIP 3074, which is a version of account abstraction, max effective balance, EOF, pure DAS, as well as a lot of other miscellaneous EIPs that were supposed to go into Pectra. And that's the stage in which we are going to be talking about for most of the talk, and then I'll continue with what Pectra looks like today. SSE, EPBS, Verkle, as well as Verkle transitions were also features that we wanted to think about and wanted to test over the course of the year, right? There are different teams working on things at the same time. Specifications are getting updated at the same time. So you're essentially you're looking for a moving target, or you're implementing a moving target. So how do we actually ship this thing? Enter Nyota Interop. So this is an event that was held in Kenya for every client team to participate in. So these are the people that are building the Pectra fork. Just a side note, we also had a Frontiers event in Kenya where we got to meet a lot of local builders, and that was extremely nice, and I hope we continue that type of format in the future. The aim was to work on Pectra as well as all the features that I spoke about earlier, and the idea was to try and figure out all the hard problems, see what we needed to do, and how do we ship it. It's an in-person event, and since most of the client teams are spread around the world, it's invaluable to actually be in the same room. You can figure out a problem within a matter of minutes instead of waiting for the person who lives in Seattle to wake up and spend the next 2 days figuring it out. There's about 120 people who were invited, and we split it into 5 work streams, so Pectra, EOF, PRDAS, Verkle, and Verkle transition. And like I mentioned, there's 120 people. We're also a very opinionated bunch, so it's not like 120 people have the same machine. There are people with Arch Linux with disabled kernel modules over there, and we need to make sure that the tools work for them. There are people with Windows machines. We need to make sure that the tools work for them. The 5 work streams make it hard to keep up with what's going on as well. There's not enough dedicated DevOps people for each client team. It's impossible to keep up with updates. Imagine 120 people messaging you, hey, I pushed this commit, can you actually deploy it for me? It's hard to test if a feature works as expected because, as mentioned earlier, the feature itself is being defined, so we don't know how it's going to look, so we don't know how to test it. And a lot of this is also tying into what Guru spoke in the previous talk. We're hoping that the execution spec tests, et cetera, help in the future, but at the time of the interop event, we didn't have that. Discussion rooms are happening all day, so it's not like we're put in one location and we can actually work on the feature. There's also meetings to attend all day while all of this is happening. And fun fact, if you ask a client dev to compile another client, chances are they'll fail at it, or they will do roughly as badly as you will. And if you're compiling Lighthouse, then you'll spend 30 minutes failing at it. And chaos really rules. So the first thing we wanted to target was how do you take care of all of these work streams, right? We added a basic process. So we had 1 document per work stream. The work stream had an implementation tracker, so you know who was doing what EIP is fixed, what specification they're targeting, what version or branch should you look at if you had questions, and sometimes also who to go to if you had questions. We had an interop shared landing page, so you just had to remember 1 URL. You go there, you follow the URL based on what work stream you're on, and you end up on a page that's actually useful for you. This really helped at least reduce the chaos for the initial discovery process. But the next part was, say I am a client and I want to use, I'm a Teku client and I want to figure out how to run Geth because we need an EL as well as CL that's working, right? And we got some help from the Ethereum Foundation DevOps team. So they helped write a tiny bot, and the bot was added to the chat. And this bot essentially made API calls to a GitHub Action CI that the ETH Panda Ops team was already maintaining. So we have the ability to build each and every single client out there, almost all the tooling that we do. It's a really nice workflow that already existed. We just didn't want to give 120 people access to our core workflow, so we wrapped it inside a nice Telegram bot and put it in a channel, so you could just do /build, follow that format, and as long as you did that, it'll spit out a Docker image that you could also access via local cache. Fun fact, 120 people, bad internet, bad experience for everyone, so having a Docker cache really saved the day there. So this sort of removed a lot of dependencies for us. By using Docker, we don't have to explain to someone which version of JavaScript they need to use. You don't need to explain anything. They were able to at least deal with that level of abstraction and continue on focusing on their fork in itself. The next part was we wanted to abstract the clients away from the client teams as well. Same thing as compiling a client. You probably don't know what flags are required for the other client either. You could follow a really verbose document, but yeah, it's a new feature. It's going to be hard. So instead, we relied heavily on kurtosis. So kurtosis is a tool we've been using to switch from remote testing to local testing. If you run that command, so kurtosis run, the Ethereum package, you will have a local Ethereum network running with whatever specification that you give it. And that specification is a simple YAML file. This one-liner sort of makes it easy for client teams to spin up a network. And I'll speak about what that file looks like and what other features the file has. But for now, all you need to know is that it's a YAML file. And this YAML file is able to give us a network, right? This means you'd never have to know what another client team is doing. You can focus or deep dive or go into the breakout rooms and actually spend your time doing that. And the kurtosis tool also uses the Docker build cache, which means we save a bunch of downstream bandwidth at the event. The next question came in, how do you actually inspect this chain? Logs are great if you use debug or trace logs. Good luck finding out what's actually happening in a meaningful amount of time. So enter Dora the Explorer. It's a custom explorer built by the ETH Panda Ops team, mostly Philip. And this also uses tools and libraries that already existed and are mostly supported by client teams or client adjacent teams or testing teams. So it's very much within the ecosystem, which means whatever new fork that exists will be updating said libraries, which means Dora would continue to get updated. And the benefit is, since it's custom built for forks, we can add whatever features we want. The database is easily accessible, so if you think up of, I want to know how many of the blocks had this very specific thing, you can just run a SQL query against the database and figure out what's happening. And we actually use this for figuring out some MEV statistics early on. It's extensible. So whenever we want to integrate other tools that the team has built, you can actually integrate it into the same Explorer. It's a nice, friendly interface. But one thing we do want to mention, it's custom built for devnets or testnets. We don't really plan on supporting it for mainnet. Mainnet requires optimization, larger states. Mainnet requires you to build for users. We're building for devs. And an example of a tool that was integrated is, this is a view of how a testnet looks. So you can see who is peering with whom, and you can look that there's one peer on the left that has a lot of other peers. Chances are that's a boot node, and that's who a lot of external people are connecting into. And you can sometimes use this view to quickly see if networking is broken in some specific manner. If you see two clusters that are really clear, chances are someone has broken networking somewhere. And we've also added support for consolidations over the last week. So you can, this is, I guess, one of the first UIs where you can actually make a consolidation. And I'll talk about where the consolidation will go soon. We're hoping that Launchpad and Beacon Chain and a lot of the other tools that you guys are used to will have this support soon. But again, this is for pioneering forks. This is for trying stuff out ASAP, custom built for the devs, I guess. The next question is, how do you validate that you can actually interop with other clients, right? Say I've done my fork, I've run my local testnet, I know that the node is working. How do I actually know that it's doing something? Introducing asserter for that. So asserter essentially asserts that it does an action and it asserts the outcome of that action. So we've written some basic tests for the client teams, and I'll go into what those tests are. And the tests can be dynamically fetched from GitHub, so we can keep updating these tests in the background as the clients continue to work on their stuff. So an example of how this looks like is you would make a 2,000 ETH deposit and then assert that the validator was activated, and it would check that it went through the entire deposit workflow using the new EIP. And you can find more about this in the GitHub page there. And this is pretty much how it looks like. You get a nice UI with a green for pass, X for fail, as well as how long it took and what sequence it went by. And if you click on a specific test, you can see all the individual steps that that test took, as well as which step it actually failed at. And we've organized all of this into a lot of tasks. So each thing is a task. So example, check consensus stability, or check or generate transaction, or whatever. And the idea is that you can combine these tasks into arbitrary tests. So every time you want to write a new test, chances are there's already a task out there. And if a task already exists, then you can just create a file that creates a new test for you. The bad part, more test frameworks. You just had to talk about one test framework. We already have legacy test framework. Now I'm talking about another test framework. It's kind of getting absurd at some point. As a result, Asserter also just integrates the other test frameworks into it. So the idea is you can continue to write your execution specification. You can continue to write execution specification tests. And Asserter just pulls them in and executes them for you against the DevNet. So one place to write the tests, multiple places to consume it, multiple places to actually see what's happening, and we're all hopefully a bit more happy with the workflow. Now the question comes in, I've spoken about like 3-4 different tools. We maybe made it easier to run the client itself, but now we're making it harder to run other tools, right? Well, the benefit of Kurtosis is that you can integrate all of these tools into Kurtosis itself. So this file, for example, specifies a Reth as well as Teku node with a specific branch that a client might have worked on. It specifies some fork parameters that I want to change. It specifies what tools I want spun up, so Dora as well as Asserter. And it tells Asserter that it wants you to that you want it to run a test from GitHub. And the test from GitHub tests everything about Electra. So what we typically did at Interop is we pinned this entire config as well as whichever clients we knew were working. And people could copy this config, modify just one parameter with what tool you or what client you are working on locally, and compare it against another client that was validated to be working. So that makes it a really smooth workflow for you. And side note, you can also do L2s on this. So for example, there's a simple YAML there that spins up not one, but actually 2 Optimism L2s. So in case you want to do L2 interop testing, you can also do it within the same workflow. Now I'm quickly going to talk about where Pectra is right now. How close are we to ship Pectra? Kind of close. Pectra as a fork since May was split into mostly 2 to 3 smaller forks. So we have MaxEB 7702 and all the staking workflow related EIPs going into Pectra itself. EOF as well as PRDAS will be moving to the next fork, and a lot of it was the outcome of NIOTA interop, as well as a lot of time spent by the devs to prototype these EIPs, figure out how they run, and then understand that, okay, maybe running all of these EIPs in one fork is going to be too much. And the idea is that splitting it into smaller chunks makes it easier to deliver these EIPs to mainnet, as well as to make sure that we're delivering it safely and securely. There still might be some minor changes coming in, but as far as we're concerned, all the major changes have been finalized for Pectra. And client teams are slowly preparing to merge their code bases in, which is a very good sign. That's typically one of the last things that happen along with the testnet before we actually decide to ship the fork. And what's left? The community is actually the hardest part and the biggest part right now. We've written, in order to help the community, we have a testnet. It's called Mekong, after the river that flows through Southeast Asia. This contains all the EIPs that go into Pectra, and the main part that we want is that people deposit a validator, try out consolidations, try out exits, update your staking guides, understand how EIP 7702 works, prototype wallets, basically try everything that you would want to try on mainnet right now. And kind of the worst case scenario is we ship this fork on mainnet and a wallet developer comes to us and is like, oh, I can't use 7702 for a reason X, Y, Z. There's still time to make changes, but that window is closing extremely quickly, and we want people to actually use this stuff and actually try this stuff out. Yeah, as a wallet developer, please add support. As a validator, look into EL-triggered exits. If you're someone who runs a staking pool or you run a staking pool on behalf of friends, try and figure out how you can do EL-triggered exits. As a node operator, run a node. We have really nice guides out there on how you can run a node. As a tooling dev, please use MaxEB or support the features. As a user, try just sending a transaction and feeling good that your workflow is not broken, I guess, and help us break it. If you're, well, all of you have a Devcon ticket, which actually means you have funds on the testnet as well. You can go to this URL and you will be able to use ZooPass to claim some testnet funds. That means you can use that funds to deposit a validator, you can run a node, you can go through the entire workflow. And we're really asking anyone who has experience with helping users in the past or helping node operators in the past to update your guides. We tried writing the FAQ for Pectra. There's a lot of changes and a lot of edge cases. So we need the communication engine of Ethereum to really spin up now, because we can't ship the fork without that sort of feedback and that sort of community engagement as well. And at the risk of not committing to timelines, I guess, the Mekong testnet is live right now. People are trying it out, time to get involved with the community. The next step would be the Holsky and Sepolia testnets. We're hoping that once the last changes go in and 1 or 2 more devnets have passed, that we can slowly start committing to shipping these as well. And the final step would be mainnet. So looks like we're relatively straightforward to shipping Pectra right now, at least. And in case you're interested in other topics that the team is handling, we have a talk about data, as well as how we're collecting data about Ethereum upgrades, how the network's doing, how blobs are performing, etc., with a tool we've built called Zatu. The talk's happening later this week, so please have a look. I think it's in Classroom D, and it's going to be an interactive session. So if you've ever wondered or wanted to dabble in data science, that's the talk to go to. And a simple example of how this sort of data looks like, this is for Mekong testnet. So we're pushing information from all of these nodes into one place. So there's roughly 95 sources of data for this. And this tells us when blocks are coming in, when attestations are coming in, and when different events are happening on the network. And the reason that this is important is if we're breaking something on the testnet, it's definitely going to break on the mainnet. So you want to have this deep network level introspection to know what's going on. as well as for blobs. We're still considering a blob increase to Pectra. And the long tail of the blob increase is ensuring that we have enough data for shipping it. And Zatu is going to be one of the ways that we can produce the burden of proof for increasing blobs on Ethereum. And these are the kind of graphs that come out of this tool. So you can actually see when blobs are arriving across these multiple nodes. And yeah, that's it from me. Thank you guys for attending. And yeah, if you have questions, now's the time.
Thank you, thank you. We're going to jump right into questions. So would you say that ETH Panda Ops could be a potential single point of failure for Ethereum's development?
I don't think we're a single point of failure. Ideally, the tools are self-sufficient. We've written them following mostly standardized languages, mostly standardized practices. I think the only weird choice we have is most of Kurtosis is written in Starlark, but it's Python-ish, so that's mostly fine. So the idea there is that any DevOps engineer could take that over if required. And yeah, if you want to help decentralize that, we're happy. Less work for us.
Thank you. Frog versus panda? Question mark.
I think we need more swag. We ran out of T-shirts already. We might need more swag and probably a similar frog-style event for pandas.
How much does these infrastructure cost?
We're actually an extremely cheap team. We run... If you ever thought we overspend, just spend dinner with Barnabas from the team, and he will make sure that you are saving as much money as you can. And most of us are kind of that vibe. We've moved to low-cost cloud offerings, so most of our stuff is in DigitalOcean. And we have some infrastructure in physical locations like Berlin or Boulder. So we've tried to reduce stuff as much as we can. Of course, there's going to be a trade-off. I think the most expensive thing that the team used to do was shadow forks. And I'm also happy to share the numbers. I think if we did a shadow fork for about a week, it used to cost us like $15,000 to $20,000. And during pre-merge, we might have spent like $50,000 to $100,000 just on shadow forks, and I think we had like 14 of them back then. And earlier this year, we switched to a snapshot-based approach for shadow forks, which means we've tanked that cost by a factor of 10 or by a factor of 15. So some of the time the team spends is also looking at the bill that we see and where we're spending money and how we can optimize that away. So it's a hard trade-off. Sometimes the trade-off space is we got to ship the fork earlier, we got to spend that money. Sometimes there's a downtime when we're bike shedding what goes into Pectra, and at that time we spend the team time into figuring out how to reduce costs.
Thank you, thank you. Is there a public dashboard to showcase these testing results?
That is actually something we've been asked, and we want to help fix. So we want to integrate the Hive dashboard a bit more closely into this landing page. Asserter actually has a public view as well, so anyone can open up Asserter and see what tests have passed and failed. But it is relatively high burden in terms of understanding what actually went wrong. I think typically the easiest way is to listen into all core devs, and usually the beginning of all core devs is either Barnabas or me giving an update on testnets and testnet progress for the week. And that's probably the best way to not spend all of your day trying to understand what's going on. Yeah.
Wonderful. Well, thank you, thank you. Let's give it up for Pari.
Thank you guys for having me.
And we will be back shortly.